Hi, welcome to MACSGATE. We are learning DBMS subject. Under DBMS subject, in today's session, we are going to start a new chapter which is called Transaction Management. In this session, let us discuss what is a transaction, what are the properties of the transactions we should ensure while we are doing the transactions in DBMS. These things we are going to discuss in today's class. Let us start the session. What is a transaction? A transaction is a sequence of operations performed as a single logical unit of work. So it's a sequence of operations which will do a particular task. These operations typically include read and write operations on the database. These are the two major operations we will have in any transaction. Suppose, what are the examples of this one? Suppose I have two accounts. I have two bank accounts. I want to transfer 100 rupees from account A to account B. This is a single logical unit of work, or you can say it is a single task. Now, this is the task. To complete this task, I need to write a sequence of operations. What can be the operations, sir? Sir, generally first I need to read the value of A, because first I want to make sure whether the account A is having sufficient balance or not, right? So that I need to do. Then what should I do, sir? I need to update account A, because from A I am taking 100 rupees. So A will be updated to the new value. After updating, I need to write back it. To the database. Then these 100 rupees I need to add to B. If I want to add to B, first I should know what is the previous balance of B. So I need to read the balance of B. After reading the balance, what you supposed to do, sir? You supposed to add 100 rupees. You supposed to add 100 rupees to account B. Then the updated value I need to write to the database. Right? So this is an example of a transaction. So it is a sequence of operations which will complete a particular task, or you can say which will perform a single logical unit of work. Hope you understood it. What are the two basic operations of a transaction, sir? The two basic operations are, the first one is read and the second one is write. When you are accessing or updating the database, first I need to read the value of the particular object. Then I may need to update the value of the particular object. So these are the only two operations which we frequently perform in any transaction. Read the object and update the object. To update, first I need to write back that value, right? So these are the two major operations. Now the question is, what are the main issues with the transactions? That means, what are the problems we might face when you are dealing with the transactions in DBMS? What are the two main issues? The first one, failure of various kinds. Suppose you are doing a transaction which is having some 6 operations. In the middle of transaction, there may be a power failure. Or there may be a hard disk failure, hard disk failure, or you can have operating system crash. Not only this one, sir, you can have the general disasters like you can have some earthquake, then the server may last the entire database. Like that, we can have any natural disasters also, sir. So there may be so many failures. That is the first problem we are having. The second problem, concurrent execution of multiple transactions. What does it mean? Suppose this is my transaction 1 and this is my transaction 2. Then if we start transaction 1, after completion of transaction 1, we start transaction 2, then there is no issue at all. But people don't have patience to start the transactions one after completion of another. What they supposed to do is they want to start both of them simultaneously. They want to start both of the transactions simultaneously. So when they are doing concurrent execution of the transactions, there may be so many possibilities of problems. What are those problems? How to overcome those problems? Okay. Suppose let me give one small example. A person wants to take a DD in a bank. A person wants to take a DD in bank. This is real-time examples are not with this database. At the same time, he want to do one more transaction, that he want to do some 1,000 rupees phone pay. Then will you wait to transfer 1,000 rupees till the completion of taking DD, sir? No. Always people try to do transferring 1,000 rupees one hand and writing the form of DD in another hand. So they want to do the transaction simultaneously. Why? Because to save the time. Because people don't have time. So we cannot avoid this concurrent execution. When you cannot avoid concurrent execution, you cannot avoid the problems, which are the consequences of concurrent execution. To save the time, it is mandatory. When it is mandatory, we need to face the problems. Then what are the problems? How to face them? That is what we are going to discuss now. Properties of the transactions. What are the properties of transactions we must ensure when we are doing a transaction in the database? The first one, atomicity. The second one, consistency. The third one, isolation. And the fourth one, durability. These are the four properties. In short, the people will say these are the properties of acid. Let me write it here, sir. Acid properties: atomicity, consistency, isolation. Now let us discuss each of these properties one by one with one example. Coming to the first property, atomicity. Sorry, sir. So atomicity. What is atomicity? In simple words, either it is 0% or it is 100%. It should not be any other number in between 0 and 100. What does it mean? Suppose there is a transaction. Suppose there is a transaction. Somebody asked what percent of transaction was completed. What percent completed? Then either it should be 0% or it should be 100%. It should not be any other number in between 0 and 100. For simple example, suppose you are withdrawing money. A person wants to withdraw money. From ATM. Right, sir? So what are the sequence of operations? The first operation he will do is he will insert ATM. Then he will enter the PIN number. He will enter amount. He will enter amount. Then amount will be debited from the account. Amount debited from account. Get the cash. That means the ATM machine will dispense the cash and we will take it. Okay. Just I written the rough idea of the transaction, sir. This is the transaction. Now, suppose some failure occurred. Some failure occurred in between these operations. In between these operations. Suppose the ATM crashes before we start inserting ATM. Then no issue. We will go to another ATM and we will do the same transaction. So people don't worry about it. Suppose all the 5 operations completed. He inserted ATM, he taken PIN and he entered amount debited and he got the cash. Then also no problem. So either 0%, no issue. So whenever it is 0%, no issue. We will go to another ATM, that's it. If it is 100%, no issue. And of course, we are happy also. Suppose a transaction has failed at this point. A transaction has failed after completion of the 4th step. What does it mean, sir? You inserted ATM, entered the PIN, entered the amount, money debited from your account, but cash was not dispensed in the ATM. Then what will happen, sir? We will worry. What happened to my amount? Where it goes? So we will be in a worry state till the amount will be credited back to my account. That means whenever the transaction was stopped somewhere in the middle of the transaction, what will happen is there is one manager who is responsible to roll back. So we are having a manager. Whenever the transaction has failed in between 0 to 100, his duty is go to 0%. That's it. Because he cannot go to 100%. So what is the only situation? He will go back. That's it. So that is the first property, atomicity. So in simple words, what is atomicity, sir? Either nil or full. Hope you understood it. So whenever it was stopped in intermediate, that may be 60%, 30%, even 99%, the manager will roll back. That's it. That is the first property. What is the second property, sir? Consistency. Sir, consistency means in simple English, you can say no mistakes. Instead of mistakes, you can say no abnormal values or unexpected values. No abnormal values in database objects. What does it mean? Let me give a small example. Suppose you are having 2 accounts. We are having 2 accounts, A, B. Let us assume the initial balance of A is 10,000. The initial balance of B is 2,000. Now I have a transaction. Which transfers 100 rupees from A to B, which transfers 100 rupees from A to B, right? Now, before starting, that is whenever it is 0%. So, before transaction, what is the total of A and B, sir? The total of A and B is 12,000. Am I right, sir? After transaction, that is after 100%, what will be the total of these two accounts, sir? It should be 12,000 only, because you are transferring some amount from one account to another account. So I should not get suddenly 32,000, or I should not get suddenly 4,000. So even after completion of the transaction, the total must be 12,000. This is one simple example of consistency. Sir, there may be so many. Okay. Not only this one, sir. So this is a simple example of the consistency. Before transaction, the total of two accounts is 12,000. After transaction, the total of two will be 12,000. Hope you understood it. That is about the consistency. The next one is isolation. Sir, what is isolation, sir? In simple example, everyone should feel that he or she is the only one who is accessing database. Okay, instead of people, you can say transactions, sir. For understanding purpose, I written it. The simple examples are, suppose we want to reserve a train ticket on IRCTC website. I want to book a ticket on IRCTC website. Then IRCTC never give a message to me that someone is already booking a ticket, please wait. So it never says that somebody is doing the work, please wait, right? So when you are booking, you will not be disturbed. You will not be disturbed by anyone. You will not be disturbed by anyone other actions or any other actions. That means I am feeling I am the only one who is reserving the tickets on IRCTC. Of course, I know the truth, but we are having an environment in which we feel that we are the only one who is accessing that particular IRCTC website. So that means they created an isolated environment so that the actions or the operations of other transaction will not affect my actions. So I should not be disturbed by any others. That is called isolation. Of course, so many people are accessing the same database at the same time, but virtually they will create an isolated environment in which I feel comfortable and isolated. Hope you understood it. The next one is durability. In simple English, you can say, how can we write is data must be preserved. Data must be preserved. That is no loss. No loss of data. Data must be preserved. 1 minute, sir. Yeah, data must be preserved under any circumstance. Whatever the reason, I don't mind, sir. The data should not be lost. Under any circumstances. That's a simple example is banking example. Suppose we are having a state bank account. We are having a state bank account in which I have some amount 5 lakhs. In which I have some amount 5 lakhs. Suppose suddenly there is a fire accident in the bank branch, or there is a fire accident in the main branch or in the branch where the server is located. Let us assume there is a fire accident on the location where SBI servers were located. Then managers should not tell to the customers that, sir, fire accident was done, so we don't know what is our bank balance. So on an average we are giving 500 rupees for everyone. Will you accept, sir? No one will accept, right? So under any circumstance, the bank authority should not tell that they lost the data. Whatever the reason may be, the data must be preserved. Whether it is a earthquake or fire accident or something else. If the total world collapse, I also don't know, sir. So, but under any circumstance, customers will not accept that the bank lost the data. When you say fire accident, automatically customer says that, who is responsible? I am not the responsible one, right? I have some 50 lakhs in my account. Please give me. Even they are having 5 lakhs, they will say I have some 50 lakhs or 50 crores I want. Right? So, under any circumstance, the data must be persist or preserved in the database. That is durability. So, these are the 4 properties of the transaction we must ensure. Now, how to ensure or how to achieve these properties? For that, we are having protocols or some mechanisms which we need to follow when we perform the operations. So, to achieve these 4 operations, what are the mechanisms or the protocols we need to follow? Those things we will discuss in upcoming sessions. In this session, we are mainly discussing about what are the properties of transaction and what are the states of the transaction. We have completed what are the properties of the transaction. Now let's go to the next one. Before going to that one, let us solve one previous question. Which one of the following is not a part of acid properties? Acid means atomicity, consistency, isolation, durability. Right? So here atomicity, consistency, isolation. Sir, D means it is durability, it is not deadlock. Right? So this is not that one. So this is our answer because it's not a part of acid properties. Let us go to one more previous question. Consider the following transaction. Consider the following transaction involving 2 bank accounts. The first one is X. The second one is Y. We have 2 bank accounts X, Y. Fine. So what they are doing, sir? They are reading X value. Then they are updating the X value to minus 50. That is X equal to X minus 50. They are writing back the X value. Then again they are reading the value of Y. They are adding that 50 rupees to Y. Then they are updating the value of Y. So hope you can understand what the transaction is intended to do. It is transferring 50 rupees. It is transferring 50 rupees. Right? Now the question. the constraint that the sum of the accounts X and Y should remain constant is that of, sir, before transaction, what is total of X and Y? Total of X and Y. Suppose the total of X and Y is 12,000. After transaction also, what should I have, sir? I should have, sir, the same 12,000, right? What is this property, sir? Consistency. The results should be consistent. So it is consistency. So the answer is consistency. Hope you understood it. Let us go to the next question. Among the asset properties of a transaction, the durability, that is the durable property, requires that the changes made to a database by a successful transaction persist, except in case of operating system crash. Sir, if operating system crashes, am I responsible? Is the customer responsible? No, sir. So customer don't mind whether operating system crash or hard disk crash, except in the case of disk crash. Sir, he don't mind what the problem is. So whether it is a disk crash, operating system crash or power failure, under any problem, customer is not responsible and he don't listen to your words. So it should persist always. That's it. It should persist always, whatever it may be, even if there is a failure of any kind. So it should persist always. That's it. Now let's go to the states of transaction. When you start or when you are doing a transaction, what are the possible states or what is the meaning of those states? Okay. So the first one, suppose T is a transaction. Suppose it was not started, it don't have any state. So whenever it was not started, it don't have any state. Suppose it was started. Suppose it was started. When it was started, we say it is in active state. That means it is at least 0.1% to 100%. So it is in active state. It is running. In simple words, it is running. Whenever it is in active state, there are two possibilities. What are the two possibilities, sir? Either it is success or it is failure. Either it is success or it is failure. Something like I can complete all the operations. Suppose the transaction is having some 1, 2, 3, 4, 5, 6. That's it. So these are the operations you are having in the transaction. If you can complete all the 6 operations, okay, that is the first possibility. Suppose it was failed in between some 4 and 5 or 3 and 4. These are the two possibilities. So the second state is very clear, sir. It was failed. That may be at any point of time, but it was not completed. Now, what this state? It completed all the 6 operations, sir. But the only left work is you not updated to the original database. So all these updations will be done in the RAM. All the operations you done in the RAM, sir. So you completed all 6 operations in RAM. You need to write back to the original hard disk or you need to write the data to the database. So you completed here and you supposed to do this at this point of time. That is called partially committed. Partially committed. That means it was done. The only work is I need to update the database or I need to write the data to a stable storage to achieve durability. So that is partially committed. Suppose while you are transferring, suddenly power failure. So while you are transferring or while you are updating, suddenly there is a power failure. Then again it comes to failure. Sir, customer don't listen that, sir, I have done all the operations in my RAM, but it was not updated to database. Will he listen, sir? No, he don't mind. So he cannot listen. Of course, he don't know the terminology sometimes, right? So you should not say, I completed the transactions in my RAM, but it was not updated to hard disk. So whenever it is partially completed and when you are updating the original database, the transaction was failed, then again you will go back to failure state, right? Suppose whenever it is partially completed in RAM and you successfully updated, you successfully updated. You successfully updated the database, then it was done 100%. That is committed. So you updated all the you done all the operations and you updated the results of the data after 6 operations to the database, right? That's it. Now whenever there is a failure, whatever the reason may be, whatever the percentage may be, is it 100% or not? No. Then go to 0%. That's it. Go to 0%. Go to 0% means rollback. Instead of rollback, we will use some technical term, aborted. So it was withdrawn from the competition. Again, it need to start from beginning. So these are the states of the transaction. Hope you understood it. It was started, sir. Okay, instead of started, you can say simply running. What is partially completed, sir? Done in RAM. Done in hard disk or stable storage also. Done in database. That's it. Failed, whatever it may be. It is 0 to 100. It is 0 to 100%. Then what you supposed to do, sir? Start from the beginning. Roll back. That's it. So they are the states of the transaction. The same one, sir. Hope you understood the meaning of all these. So that is about transactions and properties of transaction and states of transaction. In next session, we will discuss recovery management. Thank you.